In this video, we're going to walk through and actually solve some problems with hypothesis testing. In a previous video, I gave you the 6 steps to solving hypothesis testing problems. And so what we're going to do now is actually walk through and solve hypothesis testing problems using those 6 steps. And so what we want to do is first go through a couple of problems using the 6 steps. So let's look at this example that we have here. Many people believe that the average number of Facebook friends is 130. The population standard deviation is 38.2. A random sample of 50 high school students in a particular county revealed that the average number of Facebook friends was 162. At alpha equal to 0.05, is there sufficient evidence to conclude that the mean number of friends is greater than 130? Now there's a lot of information in this problem. So let's pick out the information that we know and write it down. So it says that it's believed that the average number is 130. So that's what we're assuming that the population is. So that's going to be our population mean. It tells us here that the population standard deviation is 38.2. Then we have a random sample of 50, so that's going to be our N. So of this random sample of 50 high school students in a particular county revealed that the average number of Facebook friends was 162. So of this random sample, its average was 162. And we have an alpha of 0.05. Is there sufficient evidence to conclude that the number of friends is greater than 130 people? That's going to be significant when we start making our hypotheses. So now then, step 1 for solving hypothesis testing is to state our hypotheses. Recall that our hypotheses are always going to be our null hypothesis is always mu equals, and our alternative hypothesis is always mu, and then depending upon what our problem is, it could be a greater than, less than, or a not equal to. One key thing is whatever we put mu as here, that's the number that's going to go here, and it's going to go in the same number right here. So I'm going to put down that my null hypothesis is that the mean is equal to 130. Now our problem states that at alpha equaling 0.05, is there sufficient evidence to conclude that the mean number of friends is greater than 130? So that means my alternative hypothesis is greater than 130. And since it's asking can we conclude that, that is also considered our claim. And it's very important to be able to identify which one is our claim also. So that is step 1 in solving our hypothesis testing. Step 2 is to draw the normal distribution and place the critical region. So step 2 is to draw the normal distribution. Now then, since we're looking at a greater than, that means my critical region is going to be over here, and the value in that critical region is 0.05, the alpha. Step 3 is the critical value. Remember, to find the critical value, we have to find out what the z-value is that corresponds to this. We have to do a little bit of calculation though, because remember that our table only gives us to the left and we want to the right. So what we have to do is we have to say, okay, this area over here is 1 minus 0.05, which is 0.95. This number is what we actually look up in the center of our table. So I come down to the center of my table and I'll look up for 0.95. So I come down through here. Here's 0.94. Here's a 0.95, so I need to find out where they change. And it's right here. And I've got 0.9495 and 0.9505. So recall that when we're looking at these, if they're exactly the same distance from the number that we're looking for, we take the one on the left. So we're going to take this one. And if I follow that out, that's going to be a 1.64. So my critical value here is equal to 1.64. Okay. So I found my rejection region, my critical region, and I've also found the critical value that I'm looking at. This will help us make our final determination after we have calculated our test statistic, which that is step number 4 in the process. So let me scoot down here. Step number 4 is the test statistic. And let me spell that correctly. And remember, we are going to use the formula z is equal to x bar minus mu divided by the standard deviation divided by the square root of n. So I'm going to rewrite the information that I had up above. Mu was 130, n was 50, sigma was 38.2, and x bar was 162. So I'm going to plug these numbers into the formula, and I get 162 minus 130 over 38.2 divided by the square root of 50. And I'm going to do this out step by step a little bit. So 162 minus 130 is 32. 38.2 divided by the square root of 50 is going to be 5.402. And if I take 32 divided by 5.402, I get that the z is 5.92. Remember that we are rounding to 2 decimal places because it is a z value. Once we have computed the z value, we want to put that back on our normal distribution that we drew that had our critical value on it. So instead of scrolling back up, I'm just going to redraw down here. You can do it all on one. We had this area right here as 0.05. And we had a critical value of 1.64. That was our critical value. Now we have this test value of 5.92, and I want to put that over here on this chart. One thing that we need to remember is that 0 is here, so 5.92 is going to be way down here in this area over here. So 5.92 is way down here. 5.92. So if we look at that, that is actually our test value, test statistic, which is going to help us determine, do we reject the null hypothesis, or do we accept, or I'm sorry, do we not reject the null hypothesis? Which, let me go ahead and say, we never accept the null hypothesis. We either reject or do not reject. Think of a courtroom. You never find someone innocent, you just find them guilty or not guilty, because there's always room for error. Same thing here. We're going to either reject or not reject our null hypothesis. So, as we learned in the previous videos, if the test value is in the shaded region, so if the test value is in shaded region, then we reject the null hypothesis. I'm just going to write these rules again. If the test value is not in the shaded region, then do not reject the null hypothesis. So the key is, if it's not shaded, we do not reject. Shaded, we reject. So in our case right here, it is in the shaded region. So our step 5, where we want to make the decision to reject or not reject the null hypothesis, we say we will reject the null hypothesis. For our particular problem, because again, it is in the shaded region. Step 6 says to summarize your results. When we want to summarize our results, what we're doing is we're trying to figure out, do we want to support the claim or not support the claim? And so I want to go back up to the top and look at our hypotheses. We are rejecting this null hypothesis. So we are taking this out. We're getting rid of this. Now if we get rid of this one, the question is our claim still available? So if I mark all the way through this one, is the claim still there? Well, the answer is yes, it is still there. If the claim had been up here, then no, it would not be. Anytime you decide to reject or not reject, cover up the one that you are rejecting, and that will help you determine, are you accepting the claim or supporting the claim? And that's why it's very important to write this word claim out here beside the one that you're stating as the claim, the null or the alternative, so that you can help make your decision. So for our case, we will support the claim. So when I come back down here, there is sufficient evidence. And all I'm doing is literally taking that question, the last sentence of the problem, and rewording it to say there is sufficient evidence or there is not sufficient evidence. So if I'm supporting the claim there is sufficient evidence to conclude that the mean number of friends is greater than 130. If you compare this sentence right here to the last sentence of the problem, you'll notice instead of the is, I said there is. Or if I were to reject the claim, I would say there is not sufficient evidence. I'm just rewording the question to answer it. Okay? So these are the 6 steps that you go through. We do the hypotheses, we draw our picture and find the critical value, we find our test value and put it on the chart with our critical value, then we reject or not reject the null hypothesis, and then we summarize our results. Let's try another one and see how we do. So according to the National Association of Home Builders, the average cost of building a home in the Northeast is $117.91 per square foot. A random sample of 36 new homes indicated that the mean cost was $122.57. and the standard deviation is assumed to be $20. Can it be concluded that the mean cost differs from $117.91 using the 0.10 level of significance? Again, a lot of information in there. We just need to go through and identify what information we have. So according to this National Home Builders, the average cost is $117.91 per square foot. So this right here is your population mean. A random sample of 36 new homes, that is your N. Indicated that the mean cost was $122.57. That is your X bar, your sample mean. And the standard deviation is assumed to be $20. So since it says the word assumed, that means it's the population standard deviation. Can it be concluded that the cost differs? This differs means that it's a not equal to. It's a two-tailed test using the 0.10 level of significance. So again, yes, there's a lot of information in the problem, but if you'll take it piece by piece going through, you can pull out the information that is important. Now then, let's go through our 6 steps. Step 1 is to state your hypotheses. We know that we're going to have our null hypothesis is always going to be an equal to. Our alternative hypothesis, it says differs, so that's a not equal to. So let me change that to a not equal to. And since it is the mean, we look over here for where our population mean was, and also differs from this number, so that's also an indication of what number needs to go in both hypotheses. So it's going to be 117.91. And can it be concluded that it differs? So that means that the alternative will be our claim. Step 2 is to draw the normal distribution and place the critical region. This critical region is going to be different because it's a differs, which means it's a two-tailed test. So I've got two tails, which means I'm not going to put alpha in each one. I'm going to put alpha divided by 2 in each one, which is 0.05. Which, this right here is actually the same thing as a 90% confidence interval. If I look these up, I will get the exact same numbers, and I'll get, on this one you can use either the 1.65 like we do for confidence intervals, or a 1.64, either one. I'm okay with either one. Okay? So these are your critical values, which is step 2 and step 3. So these are your critical values. Step 4 is to do the test value, the test statistic, which is the z value. So I need to look for my x bar minus the mean divided by sigma divided by the square root of n. So that's 122.57 minus 117.91 divided by 20 divided by the square root of 36. So 122.57 minus 117.91 gives me 4.66. 20 divided by the square root of 36 gives me 3.333. And when I divide out the 4.66 divided by 3.333, I get 1.398, which when I round that, because z's always have to be rounded to 2 decimal places, that becomes a 1.40. Now I want to put this on my graph over here. 1.40, which let me go ahead and put my 0 here. 1.40 is going to be between 0 and 1.6. So it's going to be somewhere about right here. So the question is, for step 5, is 1.40 in the shaded region? Is this value in one of these shaded regions? Well, no, it's not. It's in this middle part. So it is not in the shaded region. Since it is not in the shaded region, we do not reject the null hypothesis. So if we do not reject the null hypothesis, that means we are going to reject the alternative hypothesis. Okay? And we will keep the null hypothesis. In other words, you can only keep one hypothesis. So for our conclusion, is our claim still available? Well, since we did not reject the null, we rejected the alternative, so we rejected the claim. So it cannot be concluded. So looking at the way the question is worded up here, it can not be concluded that the mean cost differs from $117.91 using the 0.10 level of significance. Again, I literally took this last sentence here and reworded it. Do I support the claim or do I not support it? I'm not supporting it, so it cannot be concluded. And kept everything else. Okay? A couple of big keys here. Make sure you get the hypotheses correct. And then work on these 6 steps. These are going to be huge. This is what the statistics is all about. You're using everything that you have learned in statistics up to this point and putting it all together. You're making those inferences. Practice some of these and then let me know if you have questions.